Physics students, in this video, I want to take you back to a review of how we can use the right triangles to help us solve vector problems and expand it into if we have more than one vector connected together. Remember, we're always going to think about things in terms of x and y components of right triangles. And this might be if you're given the hypotenuse or you're given the resultant, you can break it into its x and y parts. Or if you're given the x and y parts, you can always build a new triangle that's a right triangle and make it into and find the length or the velocity of that resultant, whatever it might be. All right, so if I'm gonna take a quick example that's combining three or more vectors. We always want to kind of use this x and y table to help us organize our thoughts when we get to three or more vectors. I'll show you what that looks like. So let's say, for example, I have this vector that's 10 meters east, and I'm going to combine it with this vector that's 15 meters at 55 degrees north of east. Okay, and you see this is still east, this line here, and we're going north of east at 55 degrees, so that's how I know that. And then my last vector looks like this, where I'm 30 degrees, and I'm going to say, we could say north of west. That would be one way, because this is west here, and we're doing 30 degrees north of west at 8 meters. Now, I'm going to put all those together just in a quick sketch to give us an idea what this resultant is going to look like. I want to find out what that distance is, like how far that actually is from the starting spot to the ending spot. So I'm just putting these vectors together, tip to tail, estimating their angles and estimating their lengths. This is really just a quick rough sketch. It's not something I could use a ruler and measure. And so we're going to mathematically find that distance knowing all the x and y components. So that's our next step. All right, so how do I do that? Well, I think the best way to do that is to set up an x and y table. All right, so I'm going to show you kind of how I do this. I have an x and y table, and I'm going to just take one vector at a time and break it down into its x and its y components. I know this first vector is just 10 meters and it starts here and it ends here. So it's all x and it's positive because it's moving to the right. So I would say it's positive 10 in x and 0 in y because there is no up or down component. My next vector, though, does have a sideways component. It has some x value and it has some y value. So I've got to figure out how much of this is actually my x and how much of this is my y, okay? And remember, I'm thinking right triangles. So I'm going to break this one down into a right triangle, find out how far over and how far up it travels. And to do that, I'm going to use SOHCAHTOA. So I redrew this one here, and I'm solving now for the x and the y parts. This is the adjacent side, so I'll use cosine. So 15 times the cosine of 55 gives me that. That's 8.6. And then I know the sine will give me the y part. So 15 times the sine of 55 gives me 12.3. I'm going to put those values in here. Now, I'm still looking at my directions here, so I know if it's positive or negative. This is still moving to the right, so it's still positive at 8.6. This is moving up, so it's still positive at 12.3, okay? Please pause the video if you have any questions on where those came from. The last vector is this one right here. Again, we're going to visualize x and y. What's different, though, is this x now will be negative because we're starting here and we're moving to the left. So we'll still use our SOHCAHTOA, and when we find it, it's going to be a negative value. All right, so let's take a look at that one. I'm going to redraw it here just for a second, and I'm mapping out my x value, which is cosine. So 8 times cosine of 30 degrees gives me 6.93. Remember to add the negative sign because we're starting here and we're moving to the left. Then the y is vertical. That's going to be positive. 8 times the sine of 30 degrees, and that gives me 4. So I'm going to put those values in, negative 6.93 and 4. Then what this is telling me is if I was to draw a new triangle that went over and up to my start and my end, these are all the components that add together to give me my new x value and my new y value. All right, so that's what we're going to do. We're going to add these all up, keeping in mind that this is a negative. So I get 11.67 meters for my new x and 16.3 for my new y. So that would look somewhat like this. So this is my start and this is my end. So remember, this is where I begin my journey. I'll say start here and end here. And then I'm going to use Pythagorean theorem to figure out what distance this is. How far is it from the start to the finish on the diagonal? Okay, I'm going to plug those numbers in and I get 20.05 meters. So that would be my magnitude of my resultant. Now, to find the direction of the resultant, we're going to come back to my first picture here and notice the resultant is, we're going to find this angle right here. So I'm just redrawing what I had, and imagine that this is 11.67 over to here, and this is 16.3. So I just redrew that over here. I know it's not to scale, but it gives you an idea. Now I can use my tangent to find out what that angle is. So I'm going to take the tangent of, the inverse tangent of opposite over adjacent, so 16.3 over 11.67, and I get 54.4 degrees. And I'm going to call this north of east because I'm measuring from this line up to my hypotenuse. And so that's traveling north of the east line. Remember, the east is the reference. That's my reference right there. So 54.4 north of east, and the magnitude would be 20.05. Magnitude equals 20.05 meters at 54.4 degrees north of east. Hopefully this helps kind of to give you a quick overview of how to use right triangles and break them down into their x and y components, combining 3 or more, keeping track of the xy table where you have all of the x components added together for your new resultant and all of the y components added together for your new y value. Put that in together and solve for the hypotenuse using Pythagorean theorem, then come back, and if you need to find the angle, draw your new triangle and use trig to find the angle. Thanks, and have a great day.